Good afternoon, everyone. Welcome to um Dependency Injection Sitecore session in our own SUG Bangalore. So, today I'll just briefly explain about, or we will discuss about what is a dependency injection and why we are using it, or in a typical .NET web application, or how we will implement it. Then we'll come to the Sitecore part of it. So, let's get started. Just have a quick glance at what are the agenda items today. So, as I said, dependency injection, and we'll see what are the patterns we use to implement it, and what are the anti-patterns which we should not use it to implement it. And the couple of DI containers we will look into it, and then the Sitecore part of it. Before moving further, the first, what is a dependency injection? Before we see it, what exactly is a dependency injection? We need to understand why we are using the dependency injection, what are the problems it is trying to solve. So if you see, there is a concept called coupling. So it's not only in a software world, it's in outside also. Whenever we are trying to connect two components, so how much the strongly or loosely they are coupled. So that's what we need to understand, the measure of how strongly those two are related. How can they, whether they can work independently or whether they need a strong bonding as well. So if you see the left side picture, there is a if you see that there is a hair dryer, but that the appliances is directly attached to uh, wall outlet. So what is the problem with this? Maybe the hotel people wanted the dryer to be attached to outlet so that no guests are going to take away. So that this is a kind of a tightly coupled. But what happens? Suppose the hair dryer stops working because it is so tightly coupled with the wall outlet and the power. So if any service person need to come here to address that issue, and if he comes also, they will have to first stop the power to that room, like cut down the power to that room, and then they need to open that wall outlet, and take out that plugs, those and all pieces, and then they need to repair it. So if you then you can assume that we can how much cumbersome that work would be, and we cannot take out that hair dryer for any repairing. The similar case, if you see the right side of it, whatever we typically use outside, the same thing can be fixed with sockets and plugs. I guess we know that socket is that wall outlet. Uh, we can plug any electronic appliances. So when we introduce sockets and plugs, these two components become loosely coupled. And hair dryer, we can use it whichever way we want, and if it is a repair, we can only take it to the service person. So here the socket becomes the interface. Whenever we are able to decouple both the components like that, we can there are a lot of benefits we get in a like maintainability and extensibility. So extensibility here, it would be like I can put one more adapter to that plug and I can have more plugs. So that kind of extensibility and all. Similar way, if we come to software world, the same we may tightly couple of classes. So suppose whenever we want to consume one business library, or we want to call another class library, what we do, we will just create one new object for that class, and we will call up whatever the methods we want. Whenever we are creating a new object for that class, our class is going to be, the calling class is going to be dependent on the called class. So whenever we are creating new, we need to, so in future if we want to change the implementation, we need to change the object creation as well. So that is where dependency injection comes into the picture. It is just nothing but a set of design principles using which we are trying to achieve the loosely coupled code. That's the, in a nutshell, that is the only thing here. So if you observe the diagram, traditional, where we have the, suppose you consider as a console application or anything, main means the main root. So when we go to main, we will be creating a lot of objects. What if I have a dependency injector, maybe the another service which provides me all the classes or all the dependency objects whenever I need it. I don't need to create anything else. So it is typically kind of a collaborating. These classes should rely always on the infrastructure. This is called infrastructure here, to provide the necessary services. So whatever the services we are getting here. And if you observe design patterns Gang of 4 book, they say that program to interface, not to an implementation. So when we are dealing with the dependency injection, these objects, collaborating classes, when dependency injection provides us the objects, we are mainly programming to the interface. We are not bothered about what is the implementation behind it. So that is what we are trying to achieve. We are programming to interface, not to the implementation. And we will let's see what are the benefits it provides. So this is a kind of a, if you see, you may feel that this is an overhead. I'm creating new objects directly, and why I'm using it. Why I need to provide another service and create the objects from that. So what are the benefits it provides? There are a couple of benefits. 5 of them I listed. So late binding, as we know, if the late binding means without changing any code, then the runtime we can swap the services. Easily it can be swapped. Maybe it is an enterprise applications, we will have all the runtime environment is well defined before. But what if it is a kind of a standard software where you may not have those runtime environments well defined before. So that time we can, if we use the late binding feature, that we can swap the features. We can swap the number of services. And next would be extensibility. Extensibility, it's a kind of a day by day we use, like we extend couple of classes the functionality, and we reuse it. And we reuse it in such a way that we might have not planned it before. If we take the analogy of whatever we have seen the hairdryer previous example, when the hairdryer, the decoupling we need to do, then we are introducing plug and sockets. But when it was introduced, we had no idea on whether this plug can be used anyway with n number of electrical appliances. So these new appliances, whenever we are coming up, because assume that the computer was not there. If computer came now, computer needs power, and we are using the same plug. The similar way, that's a kind of a extensibility we can use it. It's a kind of a rewiring electrical appliances using any plugs and sockets. So that's a kind of extensibility we are talking about. And parallel development, yeah, we see in a kind of a separation of concerns make it possible to develop code in parallel teams. So in a scenario, like assume that there is one team is building you for services, kind of a maybe web API or web services or anything, and you are the consumer of the services. Maybe you are another part of a team where you are implementing maybe web application or Windows application, whichever it is, and you need to consume all those services. So when we define these contracts in between, kind of an interface, so I will provide all these methods, so it would be easy for both of them to work independently. Similar case, it's within the team as well. Like if I am working on some feature, and if another engineer is working on another feature, we need somewhere to collaborate to integrate these pieces. So that time the contract, whichever we defined using the interface, will be helpful, more helpful. And another feature would be maintainability, because classes we define with the single responsibility principle, and it does only one thing, and if it does only particular one thing, it is easier to maintain it. Yeah, that's what will tell the single responsibility principle. And testability, it is one of the big feature. Like whenever we are not depending on the class libraries, like newing up the dependencies, we can easily test it. Kind of a unit testing I am talking about. So in a way, the ability to replace the intended dependencies with test specific replacement, mean we use the mock objects to test this unit, test this just the piece of maybe the consumption. We are not bothered about the consumption of the another class. We will just provide the mocking object so that it will be easy for us to just test that piece of the code. This is the biggest feature for the loose coupling. And as if we see, like these are all the features for providing the dependency injection. Let's look at to how many ways like we can implement these features. Like there are dependency injection patterns available. So let's look into a couple of patterns here. Constructor injection, property injection, method injection, ambient context. So if you go to any and just one thing is, these all the concepts are common to that object-oriented programming. It's not anything specific to Sitecore or .NET I am talking about. These are like general best practices principles. So if we see the DI pattern catalog, like how do we implement these dependency injection patterns? There are couple of ways we can implement is, so main thing is constructor injection. So whenever we are creating the, I will show you in a demo that how it features, but otherwise whenever we are defining any dependency, we will define it in the constructor as constructor only, so that anytime any of your method which is part of that class consumes that service, it will be already available, because whenever you need to call the method, you need to go to the constructor. So compile time checks would be there, and it would be always available for you, that service. So kind of advantage is that injection is always guaranteed, and it would be easy to implement it, because it is defined on the constructor only. So it's a kind of a parameter we provide. And all the frameworks support this. All the dependency injections frameworks will support this constructor injection. Based on the name itself, we can identify. So constructor injection is more of a injecting using the constructor, using the parameters and all. Same property injection, it's a more of a using get and setter properties, and we are injecting the dependency based on the property. Same goes to method, we are injecting to the individual method. It applies. This is best used when we have when each method call we have a different dependency. So that is used in that context. So ambient context is kind of a, if suppose some dependency used by many classes, so that case we can create the static accessor for the dependency, which makes it reachable for all the clients. But this is ambient context is more used for the cross-cutting concerns. It's kind of a, if you want to use the security or caching or kind of a logging, then we use all ambient context, but it is rarely used pattern here. Now we have seen this basics of how we implement it. It's also better to see in ways we should not implement it. Kind of anti-patterns. So I guess everybody aware of anti-pattern. So anti-pattern is kind of a description of commonly occurring solutions to a problem. When we are trying to solve it, we are introducing in negative consequences. So we are trying to achieve one solution, but when we are introducing that solution, we are we are also introducing a couple of negative consequences. So it's a kind of a couple of them. Control freak. So control freak is it's a basic one. Whenever we are creating a new object for any class, means we are introducing a dependency there. Until unless in future if we want to modify, we need to compile the code as well when we modify. So testing would be very difficult. The same everything. And bastard injection kind of a, sometimes what people does is, I have a constructor, I will introduce one more new constructor kind of a use for just for unit testing. So in that cases they introduce the bastard injection kind of a constructor injection, but this is a constructor overloaded injection just for their specific scenario. But this pollutes our dependent injection part of it. The similar way, constrained constructor means we need a multiple overloaded constructor. So where we need to pass particular parameters and all. This covers that part. Service locator. There is a lot of debate on the service locator, whether it is a pattern or anti-pattern. But as far as my digging goes, this falls under anti-pattern because it provides us the dependencies, but we are not creating any dependency in the our consuming class. But it provides from one locator, the service locator, but it is not guaranteed always. It's a kind of a lot of just I'm touching main point of it, but there is a lot involved on each and every pattern as well as anti-pattern. Kind of that's it on the basic thing. I want to focus more on the demo. I don't want to go too much into the theory because you can find all the references in the theory online. So to work on this dependency injection and all, we use couple of containers. So containers means nothing but another third-party library. So they provide us these dependency injection features, kind of a lifetime management, interception, and composition route. These are different topics or different concepts the dependency injection container provides. So I just listed a couple of containers here, like Spring.NET, which is a port of Java Spring framework, and Ninject, Structure Map, Castle project, Castle Windsor, and Microsoft own Unity framework, Unity dependency injection container, and as well as newly with the .NET Core, they have Microsoft had introduced one more dependency injection, like Microsoft dependency injection, which Sitecore has used for implementing its own DI framework in Sitecore 8.2. So these are the kind of a couple of frameworks we use. I specifically worked on Spring.NET and Structure Map in my .NET projects, not into the Sitecore. Let's look into the demo now. Here, if you observe, I just created one. I guess you are able to see this. Okay, I just created one sample MVC application which comes by default when we are using the templates Visual Studio. I have not introduced anything else.
Okay.
And yeah.
Sorry, we can only see all your screens thumbnails. Okay, there you go. All right.
Yeah. Okay. So I just created one. This is nothing to do with the Sitecore. This is just a normal .NET application which I have created MVC with a latest version, not the core MVC for .NET 4.5 I created. And if you see here, these all are the controller models and views. And so if you see here, I have written one to-do list controller. Okay, it's already open. So what this to-do list controller does is it calls one get to-do list method, which is present in uh, models. So to-do.cs. So if I see here, this is having couple of property, title, date, comment, and as well as I created interface here. I to-do list service. It does only one thing, get to-do list, and so I have implemented one more to-do list service. So this consumes this interface and this implements that interface method. I'm just hard coding some of the data. This can be get from either data service or some other service. But if you come to now to to-do list controller, I need to use this consume this get to-do list service. So typically what we do is I may do where model, maybe to-do list service. So kind of this is the typical way we see. I have just one index method which I am trying to call. So I'll just call get to-do list method, and I'll create the new to-do list service. But whenever we create the in this way, newing up the impedance, this is what we call control freak. So control freak anti-pattern, because this volatile dependency we are directly creating it here. So in future, if I want to test this index method, how do I test? Means I can't pass any mocking fake DB or anything else. So and whenever I want to test only this piece, I cannot even do test because it goes to get to-do list, and it goes to get to-do list, and if it is having some other database, even that goes to that database. So kind of a I might be performing integration testing there. Means I'm checking full flow, but what if I just want to quickly check this piece of it? So I assume that this get to-do list will return me the data, and I just want to check whatever the functionality here. But I cannot do that once I am introducing new to-do list service, and late binding also I cannot do because I cannot pass any other runtime runtime class object, because as soon as we are newing up, it is kind of a static here. Means I cannot modify it unless I change the code and compile and put it in the another environment. So what we are trying to do in another way is I'm just creating one property here. If you observe the if you observe the type of it, it is I to do list service. So when we are doing it, I need this to do list service property to be initialized. So how do I do that? I may do it here. I am doing with the constructor injection. So I talked about there we have seen constructor injection, method injection, property injection, and ambient context. I'm just only covering controller injection. It is the main part of it. Property and method and ambient, we use it in only particular scenarios. So if you see here, I just created another controller, sorry, another parameterized constructor, to-do list controller, and I am passing I to-do list service here, to-do list service. I'm assigning it. So if you observe here, nowhere I have mentioned the implementation class. I have not mentioned anything related to to-do list service. I am only working on the I to do list service, which is the interface. So as I mentioned, like we are programming to interface, not to the implementation. So if you remove this code, then if you see it, I'm just calling to-do list service whenever I am calling this particular index action method, because this is already available for me. So I don't need to even null check as well, because I just do the to-do list and model, and I will be populating that model. So if you see here, how how I am getting the implementation into this, because if you, I guess you already know, but I cannot create new, sorry. Because I cannot create a interface, because this requires the implementation of it. So if you see, cannot create the instance of the abstract class or interface. So we cannot new up the interface. We need to have the to-do list service. But if you see in the code, I have not provided anywhere the to-do list service. So how exactly is it getting? If you see here, I am using the DI container. We'll check the references here. Structure map and structure map.web. If you see here, these two. So this is the DI container I am using here. If you see those two dependencies, I have introduced the structure map container. Whenever I install the NuGet package, so what I get is here, if you close everything, I will get the abstract, so structure map MVC, and this whole bunch of dependency resolution things here. So where exactly I need to inject my dependencies? So if it come across the default implementation of structure map, if you go to default registry, this is where we are doing. Okay. There are three ways we can inject the dependencies using the DI containers. One is the XML, so which we typically used to do in previous Spring.NET, whatever it was, the previous old frameworks, because XML has its own usages, because you don't need to compile any code and you can just directly inject the dependencies from the XML. But problem would be, you don't have, this is so verbose and we cannot do any compile time checks. So that is what the XML part of it, but we can do using the XML or using the registration kind of a, if you observe here, kind of a, I am putting I2do list service use, sorry, I guess use to do list service. So kind of I'm telling you to the system, saying whenever you come across I2do list service, you inject this to do list service object. So that is a way I can just register it. But this is also one more problem would be, I need to inject each and every individual interface and the implementation of it. But what if kind of a third way is auto registration? So I can do the auto registration in this way. Kind of what it follows is, it follows the some particular conventions. So kind of if I2do list service and to-do list service, if you observe, we follow this the same, just it would be names would be in such a way that only it would be difference would be I, just the interface will have extra I as its prefix, but the implementation would be having that kind of a prefix. So kind of a those kind of a conventions it uses, and it does the auto registration of it. So I'm not modifying anything, any code from the structure map, whatever it got. So it is telling scan all the calling assembly, and using the default convention I'm telling this I, and it is not having I. This default convention it uses, and it just register all the these interfaces and implementation part of it. So that is the reason we are getting directly the injection here. So let's look into how it will come here. Maybe I'll put the debugger. So okay, it is building. Yeah, if it is a typical MVC application, so you will get the default MVC pages. Let it load. Okay, so this is a kind of a default layout with MVC. Let's navigate to-do list controller index method. So to-do list. So whenever I'm initializing, whenever I'm coming to this index method, automatically constructor, obviously it will generate. So if you see the service, if you observe it, it is having the model's to-do list service. So if I go further, it will initialize this service, which is the implementation part. Then I go further, so it comes to my index action method, and I'm directly calling on the to-do list service, and it is having get to-do list. So let's see where it goes. So obviously it goes to here, but if you see, nowhere we have created any direct dependency on the to-do list service implementation. We are only coding for the interface. So if you see here, I will just get whatever the data here, and model, if you see, you will get all the data. Okay, let it load. But yeah, it will load and it will just give us a normal view. But otherwise, this is a typical way we do if we are using any container. It's a more of a, I'm just showing you one container, the structure map example, but typically most of the things works in a similar way. They all provide XML registrations. Using XML we can register, or using direct both the way, either through the interface to implementation directly injecting there, or the auto registration based on the conventions. So if you see here, it just outputted the model. So if you see here, it's nothing but I don't have anything fancy in that index HTML. So I'm just outputting the model and creating the table and outputting the model. So to do. So this is a kind of we do in a .NET world, and there are a lot of things involved when we are introducing these things, because kind of a object, whichever object it got created, that lifetime of it, and interception using the cross-cutting concerns, and the composition route. When exactly we need to register these all injections? Typically, it would be on the composition route. So for us, for MVC, it's a more of a global ASXCS. So kind of that is the application route, right? So where we inject all these dependencies, or all the auto registration will be done at that point. So these kind of a multiple ways it will happen if we are doing with the web forms, if we are doing with the Windows, if you are doing with the MVC, kind of a composition route would be different. But typically lifetime management would be handled pretty much similar, and the interception, that cross-cutting concerns we can provide. That's more of aspect related programming, aspect oriented programming. So that's a different part of it. But this is the way typically we do it for the just a .NET. So let's look into MVC part of it. So before going further, I'll just show you. This is a typical dependency injection documentation. But one thing I want to mention here is, with the 8.2, what Sitecore does is, if you see here, Sitecore implementation of DI is based on the Microsoft extension dependency injection. So these abstraction, it is using it. So this dependency injection is specifically created for kind of Microsoft extension is typically created for the .NET Core, that whichever is a new platform, .NET Core platform, this has been created. So from 8.2, this is Sitecore is using this dependency injection framework. So how do we configure using in Sitecore? So typically, if you see here, we can directly inject the dependencies using the code, using the XML, as I talked about previously. Using the XML also we can do just services and services type. We can provide the um, whichever the interface. This is the namespace, complete namespace, and implementation type. So my service is the implementation of my service, and this is the namespace. The similar way we can just do it, the registration of it. But another way would be to register through the code. iService configurator. If you see add scoped type of my services, add transient my service website. So this is the more of a, this is interface, this is the implementation. So whenever it sees my service, it automatically inject this implementation. Same way my service base implementation. So we will see the demo of registration in code, but we can also do the configuration as well. So for that, again, I have created, I have installed the Sitecore latest 8.2, and okay, let me load the. Sorry. Okay. Okay, it is loading. I have put a di demo local.com. Nothing I am doing in the template level, but we can do template and all. But I am just showing you the basic one. How we can do the same example we have seen the to-do list controller. I am putting same for Sitecore as well. But we can typically do the template and the model of that content model and all. But here, if you see, I just created one to-do list controller, just the same what you have seen there. I to-do list service, and similar way I to-do list service and all. So how exactly we are going to register? We are not going to use a structure map container here, because already Sitecore came up with its own DI using the Microsoft extension injection. So we will use that part of it. So again, if you see the to do, the same implementation of it, nothing changed. I just want to go with the same example so that we can easily relate it. And if we come here, that is in a business library, and there's a view is same. There is no change here. Just see here, I have introduced one more register di.cs. So if I go to register di.cs, this is the only this is where all the magic happens. So if you see here, Sitecore extensions dot dependency injection. If you do, because we are referring it to this. Okay, let me show the references as well. I am adding Microsoft extension dependency injection and dependency injection abstractions, and as well as Sitecore client and kernel. These all the things I'm injecting here. If you observe, okay, I opened demo. This is my web root for my di-demo.local.com, and if you observe the bin, you have here Microsoft dependency injection abstraction and dependency injection. So these are the couple of things it uses for the DI container. And if you observe, I am referring these things, and we need to implement the iServices configurator, because this is where all the services will be initialized in the Sitecore. So if you observe this is coming from Sitecore dependency injection, and we need to implement only one method, the configure, and it would be coming with the service collection. So it's a more of there is already a services collection. I am just adding it my own implementation as well to the services collection. So this is the way I'm registering it. So if you see, just ignore the below parts. Just concentrate on this part: services collection, add transient, I2 release service, and to-do list service. So I'm registering in the Sitecore that whenever it come across I2 list service, use the to-do list service. And add transient, there are a couple of things: add transient, add singleton, add scope. This is more of a lifetime of this object we are controlling it. Add transient means it would be similar for that whole web request. Singleton would be kind of a whole that context of it, and the scoped will be working in differently. So kind of add transient, whenever it try to come up with this, it will create the new object. So next step would be okay, let me do one thing. I'll list out the steps so that it will be easy to remember. So sorry, okay, if I go to register DI, one CS library I'm introducing, we need to refer it to Microsoft Dependency Injection and Sitecore Dependency Injection namespaces, and we need to implement iServices configurator, which gives us the configure method. And we can add our register our components. So second would be, so we need to tell to Sitecore that to call this method, right? Call the particular register DA. So we need to hook it up. So we need to create some just custom patch config. So which we will register. So initialize this register DI. So these are the two things we need to do. One thing is register DI, Microsoft Dependency Injection, this all of it. And sorry, I can zoom it. So register DI and Microsoft Dependency, these are all the namespaces we need to use. iServices configurator, we need to implement this interface and configure method and register our components. Jet custom patch we need to create so that to register this DI and initialize it. So first we have seen that iServices configurator and configurator iService collection, and I'm adding this I2 service. And let's see I have also created app config include. So jet custom DI register. If you see here, we need to do is Sitecore services and configurator. The similar way I'm just mentioning the CDA register and namespace. So this is the only two pieces we need to do here. If we do, and if we come to, okay, let me log in. Let's inspect the Sitecore. Sorry, show config. DI demo. Excuse me. So show config.aspx. If we inspect, we need to see this inside the services. So whenever it is running, it runs this also. Okay, it's loading. In the meantime, we also need to load. So there is one more admin page is available from 8.2, where we can see all the show services, all the services which are registered. So let me load it that also. So here if I see register, okay, if you so if you see here, it comes, okay, configurator type. So it is added into services. So these services runs. If you observe the just above that services, Sitecore default comes with Sitecore services.infrastructure, Sitecore dependency injection, that components, whatever it is. So we are just patching there to run our own registration as well. So when we run it, if you, okay, I guess this every time we need to do whenever we do it. So let's see whether our newly registered component came up or not. I just built already, so we should see this I-to-do list and to-do list. So this is where it came up with show services config. So there are a lot of, if you see here, you will get service type and service implementation and lifetime. This is what kind of a interfaces, or abstraction or whatever it is, and this is what the implementation classes and the lifetime of this each one. So let's go to last. Okay, if you observe here, this is where we are able to see Sitecore SCDI demo, business, I-to-do list service, and to-do list. This is what, and if you see the right side implementation, so this is where I'm trying to show you. So this is what the implementation of it, and sorry, and if you see, this is the transient which we have added. Similarly, controllers I'm adding with another one, but this is a typical way we need to add our kind of a registered or implementation to I-to-do list. So this is very good page for us admin tool, where we can debug it if it is not coming up, or if it is properly registered, we can double check here. That is what the kind of in a nutshell how we do it. And there is one a very nice article from Camfigi, dependency injection in Sitecore 8.2. What he did is he created one more. Sorry, at last it is. Yeah, he created one more service collection extension where it automatically register all our by scanning through our assembly. It does all the registration of our controllers and our this whatever we did, the class and the object mapping. So here this to-do list service. So we no need to do all these. Automatically assembly will pick based on the convention, as I said in the structure map demo. So this is the more of a, this is what I added, the service collection extension from Camfigi, whatever he provided. So this added all the things, but we can use in this way, but we can also use in this way. Just I wanted to show you how we can register manually, like one by one, because it also gives a compile time errors. Yeah, in a way, that's pretty much about it. So get back. Yeah, if you have any questions, I'm just putting my hands on the Sitecore part of it, but I did kind of in production. I only implemented the Spring.NET and structure map, and I did for my .NET projects. Yeah, any questions, Annie, or like, okay. Hello.
Yeah. Great. Thanks, Gopi. I don't think there are any questions right now, but if there are any questions, do feel free to reach out to Gopi.
Yeah, sure.
Yeah, through LinkedIn and all the channels, any of the channels, you can reach out to him. And cool.
Yeah,
All right, that's it then. Thank you so much, everybody, for attending. The recording and everything is going to be uploaded, I think, in a week's time. So thank you again for joining.
Thank you.
Thanks, Gopi.